Hello friends, here we are going to solve a question from Indian Regional Mathematics Olympiad or RMO of 1992. And here is the problem statement. It says that if A, B and C are three positive integers having no common factors, and if 1 by A plus 1 by B is equal to 1 by C, then show that the summation of A plus B is a perfect square. Okay, so the problem statement is not difficult to understand, but how can we proceed in order to tackle this problem? Let us first try to come up with some practical examples which can support the given problem statement. And in fact, we don't have to do a lot of brainstorming before we get a few practical examples quickly. I can immediately think of two. Let me show you those two practical examples. One is 1 by 4 plus 1 by 12 is equal to 1 by 3. And another example could be 1 by 10 plus 1 by 15 is equal to 1 by 6. So in these two examples, you see that the numbers A, B and C, for example, in the first case, let's say A was 4, B was 12 and C was 3, and A, B and C did not share any common factor. In the second example, A was 10, B was 15 and C was 6, and here also A, B and C did not share any common factor, but we see that in each of these examples A and B did share a common factor. Now the question gives us the condition that A, B and C, when all these three are taken together, they will not share any common factor, but it does not tell anything about the pair of the numbers, whether A and B as a pair will have any common factor or not, or whether B and C will have any common factor or not, or whether C and A as a pair will have any common factor or not. So I mean, even if the pair of the numbers share any common factor, that does not violate the condition given in the question. In fact, in these practical examples, we saw that in each of these cases, A and B actually had common factors. Okay, so let us first note down these observations. According to the question, first of all, A, B and C do not share any common factor. So their GCD or greatest common divisor should be 1. So this is our first observation. So we have GCD of A, B and C equal to 1. Okay. Now what about the GCD of A and B? Well, A and B may share any common factor, may not. In the given examples, A and B did share a common factor. So okay, even if A and B are relatively prime and they don't share any common factor, it's still not a problem. Let us just assume that the GCD of A and B is some number G. If A and B are relatively prime, then their GCD will be 1 or G will be 1. Otherwise, they will share some common factor, so they'll have some GCD. For example, in the first case, we had A equal to 4 and B equal to 12, and in fact 12 was a multiple of 4. So in that case, GCD of 4 and 12 was 4. In the second example, A was 10 and B was 15, and their GCD was 5. Okay. Now since we are assuming that G is the GCD of A and B, that means A is a multiple of G as well as B. So you can write A equal to some Gx and B equal to some Gy, where this G is the greatest common divisor of A and B. Now since G is the GCD of A and B, we can say that the GCD of these numbers X and Y should be 1. That means X and Y should be relatively prime to each other. Okay. What else? Can we have any other observation from here? Okay. We know that the GCD of A, B and C is 1 because they do not share any common factor. And what is G? G is the greatest common divisor of A and B. That means G is a factor of A as well as G is a factor of B. And because A, B and C taken together do not share any common factor, G and C should also not have any common factor. Or in other words, the GCD of C and G should also be 1. That we have to keep in our mind. So these are initial set of observations that we have. And we have to develop our logic on the basis of these observations in order to prove the claim made in the question. Okay. First of all, from the given example, we see that in the first case, A plus B is 16, which is a perfect square. In the second case, we see that A plus B is 25, which is again a perfect square. And, well, of course, the GCD was 4. In the first case, the GCD of A and B was 5 in the second case. Now, how can we develop a constructive logic based on these observations in order to prove the claim made in the question? Let us just rewrite the given expression. We have 1 by A plus 1 by B is equal to 1 by C. Just replace A by Gx and B by Gy. So we have 1 by Gx plus 1 by Gy equal to 1 by C. This is just another way of writing whatever is given in the question itself. Now simplify this, we get Gxy equal to Cx plus Cy. Okay, now this line is important. Observe this line carefully. It says that the left hand side is divisible by x. Therefore, the right hand side must also be divisible by x. Now, Cx is a multiple of x, so you don't have a problem there. That means in order to make the entire right hand side divisible by x, Cy should also be divisible by x. But how can that be possible? Because x and y are relatively prime. We know that the GCD of x and y is 1. So in that case, how can Cy be divisible by x? Well, the only possible way out here is that C has to be a multiple of x. Only in that case, Cy can be divided by x properly. That means C is a multiple of x. And by drawing a similar logic, we can also establish the fact here that C should also be a multiple of y as well. That means C is a multiple of both x and y. But since x and y are relatively prime, that means they do not share any common factor. Therefore, C has to be a multiple of the product of xy. Or in other words, we can write C equal to some kxy. C is a multiple of the product xy. So C equal to some kxy we can write. Okay, let us just replace the value of C by kxy in this line. So we get gxy is equal to kx square y plus kxy square. Simplify this and we get g by k is equal to x plus y. Okay. Now, the right hand side here is x plus y, which is an integer. Therefore, the left hand side must also be an integer. That means g should be a multiple of k, so that k can properly divide g. But how is that possible? Because k is a factor of c. Here you see c was equal to kxy, so k was nothing but a factor of c. and G and C did not share any common factor. Here you saw C and G had a GCD of 1. That means G and K should also not share any common factor. Now if G and K do not share any common factor, then how can K divide G? But K has to divide G in order to make the left hand side an integer. So the only possible solution here is that K equal to 1. There is no other way out. But if you put K equal to 1, then everything settles down. So put K equal to 1 and we get G equal to X plus Y. Okay. Now again, one more observation here, that G is always greater than 1. Because X plus Y, both of these are positive integers. So the right hand side is always greater than 1. Therefore, G should also be always greater than 1. That means the GCD of A and B is always greater than 1. That means the initial doubt that we had initially that A and B may be perhaps are relatively prime is not true. A and B cannot be relatively prime. That means A and B should always have some common factors like they had in our given examples. In the first case, the common factor was 4. 4 and 12, they had a GCD of 4. In the second case, 10 and 15, they had a GCD of 5. So A and B should have some valid GCD. They must not be relatively prime because G has to be greater than 1. G is the GCD of A and B. Now we're almost done here. We got G equal to X plus Y. Okay, so what was the question basically? The question wanted us to prove that the summation A plus B is a perfect square. So let us do that. Let me write it here. A plus B. Now what is A? A is Gx. What is B? B is Gy. So A plus B is equal to Gx plus Gy. A plus B is equal to, take G common here, G into X plus Y. A plus B is equal to, now what is G? G is X plus Y. So the right hand side becomes X plus Y whole square. That means A plus B is a perfect square. So here we have proved, and let us just verify by our examples. In the first case, we had A plus B, which was 16, which was a perfect square. And in the second case, we had 10 and 15. Their summation was 25, which was again a perfect square. Now in the first case, the GCD was 4. Now that means X was 1 and Y was 3 in fact. 4 into 1 is equal to 1 and 4 into 3 is equal to 12. So X was 1 and Y was 3. And the summation was 16, which was basically 1 plus 3 whole square, or 4 square in other words. That's what we got. A plus B is X plus Y whole square. In the second case, the GCD was 5. That means in the second case, X was 2 because 10 is equal to 5 into 2, and Y was 3 because 15 is equal to 5 into 3. So the summation 10 plus 15 was 25, which was basically 2 plus 3 whole square, or 5 square. So here we have proved the claim made in the question, friends. I hope you have enjoyed the video. So please feel free to like, comment and share and subscribe to my channel. Thank you.